everyone, welcome back to my channel. In today's video, we'll see Cloud SQL with Terraform. In this lab, we will create a Cloud SQL instance, install the Cloud SQL proxy, and then test the connectivity with MySQL client using Cloud Shell. So let's start the lab. Let's activate Cloud Shell. Here, let's first set the project ID. Let's copy this. So project ID, you can get it from the lab only. So let's copy this project ID. Now we have updated the project ID. Next, let's download the necessary files. So first we will create a directory by this name SQL with Terraform. So here mkdir means make directory. It will create a directory with this name. Then we will change to that directory by executing cd command followed by that directory name. Later we will use gsutil command to copy the files from this storage bucket. So we have this GSP234.zip file where Terraform scripts are hosted, so that we will download it into this directory. So let's copy this. So now you can see we are under this path SQL with Terraform. So this is the directory. So when we do ls, so we can find this zip. Next we will unzip that. So when we do ls now, we have unzipped this. We have this main.tf, outputs.tf, variables.tf. These are the Terraform scripts. Next in task 2, we will understand the code. So in main.tf file, we have these resource blocks defined. So let's try to understand that. So let me cat this main.tf file. So this Terraform script provisions a SQL instance using the Google Cloud Provider. So here under provider block, we are mentioning the Google and we are specifying the versions. So this uses Google Cloud Provider for managing resources, and it uses random provider to generate unique IDs for naming. Next under resource block, so this is the resource block. Here we are creating a Cloud SQL MySQL instance. It dynamically names the instance. And then under project region and database version and also master instance name, it's picking this from the variables.tf file. Next under settings, here we are defining the machine tier, activation policy, disk autoscaling, and we are also defining the Google App Engine authorization. Next under this backup configuration, dynamic backup configuration. This uses the dynamic block to configure the automated backups. So here we are passing this binary log enabled. So this is useful for point in time recovery and replication. Next under IP configuration, this block of code configures network settings like IPv4, private network, SSL, and it uses dynamic blocks to allow multiple authorized networks. So we also have this a block of code. So this sets instance location, and we are defining the maintenance schedules for Cloud SQL. So under maintenance window, we are defining this schedule. So this block of code defines the storage and pricing. So here we are defining the disk size, disk type, pricing plan, and the replication type, availability type. So all these values, it gets picked up from the variables.tf file. Next is the replica configuration. So this configures the replication settings for failover, SSL and authentication. So here we are passing the CA certificate, client key, password, SSL. So this is required for failover, SSL and authentication. And under timeouts, we are limiting how long Terraform waits when creating or deleting the Cloud SQL instance. And this block of code, it creates a new MySQL database, and it uses count as 1 to conditionally create the database only when the master instance name is empty. And in this block of code, we are generating a random 8-byte password for SQL users. So under byte length, we have specified it as 8. Next, this block of code is to create a user. So this will create a MySQL user for the database, and it uses random password generation if the user password is empty. So overall, using this main.tf, we are creating a MySQL instance, and we are configuring the backup, networking, security and the replication. And we have also defined the dynamic configuration for backup and the maintenance configuration, and it also creates a database and user with a random password. So next we will need to update the variables.tf to use the project ID and the region. So here click on open editor. So under SQL with Terraform, click on variables.tf. So let's copy this project. Here update the project ID, and we need to update the region as well. So let's copy this region. So here we need to update the region to Europe West 4. So we have updated project and the region under variables.tf file. So once done, we can just save this and click on open terminal. Let me clear the screen. So next we need to run Terraform. We need to execute Terraform init command to initialize a working directory which contains Terraform configuration file. So we execute this command to bring the working directory up to date with changes in the configuration. So let's copy this, execute it here. So this is initializing the backend. Now this Terraform has been initialized successfully. Next we need to execute Terraform plan. So when we execute this Terraform plan command, it will create an execution plan. Terraform will perform a refresh, and then it determines what actions are necessary to achieve the desired state which is specified in the configuration file. So we execute Terraform plan command to know what all changes will be made before actually executing it. So let's copy this. See, when we executed this, so it will show Terraform will perform the following actions. So here it is telling the SQL database will be created, and here plus means all this gets created, and then instance master will be created, user, it is creating a user and it is generating a random password. Here under plan 5 to add, 0 to change, 0 to destroy, which means 5 resources will be created. This is how you verify it before running Terraform apply command. So here the option -out argument is used to save the generated plan to a file. So TF plan, under TF plan this output got saved. Next we will execute this Terraform apply command, and this command is used to apply the changes which is required to reach the desired state of the configuration. So let's copy this. Let me clear the screen. Let's do ls here. So you can see TF plan got generated. Now we will execute this. See, now it's creating a username password. It's randomly generating it, and it is creating the SQL database. It's creating a SQL instance. Now this is complete. You can see resources 5 added. So once it's done, you can click on check my progress. We had created Cloud SQL instance using Terraform script. Next we'll proceed with task for Cloud SQL proxy. Cloud SQL proxy provides secure access to your Cloud SQL second generation instance without having to allow list IP address or configure SSL. Accessing your Cloud SQL instance using the Cloud SQL proxy offers these advantages: secure connection. The proxy automatically encrypts traffic to and from the database using TLS 1.2. SSL certificates are used to verify client and server identities. Easy connection management. The proxy handles authentication with Cloud SQL, removing the need to provide static IP address. You do not need to use the proxy or configure SSL to connect to Cloud SQL from App Engine, Standard or the flexible environment. These connections use a built-in proxy implementation automatically. The Cloud SQL proxy works by having a local client called the proxy running in the local environment. Your application communicates with the proxy with a standard protocol used by your database. The proxy uses a secure tunnel to communicate with its companion process running on the server. So this is a diagram which shows how the proxy connects to the Cloud SQL. So this is the client machine, and we see client application, proxy client, and how both are communicating. It's communicating via local connection. And then we have this Cloud SQL, we have proxy server and the instance talks to the proxy server, and there is a TCP standard port here, and this proxy server connects to the proxy client via TCP secure tunnel. Next we'll proceed with task 5, installing the Cloud SQL proxy. So we will download the proxy. So from this we will download the SQL proxy. Let's copy this. Next we'll make the proxy executable by executing this command chmod +x, which means it is adding the execution permission for this Cloud SQL proxy. Let's copy this. So this is that directory, and it is having this executable rights. So when we start the proxy, we need to provide few information like what Cloud SQL instance it should establish connections to, where it will listen for data coming from the application to be sent to Cloud SQL, where it should find the credential it will use to authenticate the application to Cloud SQL. So the proxy startup options we provide determine whether it will listen on a TCP port or on a Unix socket. If it is listening on a Unix socket, it creates the socket at the location we choose, usually /Cloud SQL directory. For TCP, the proxy listens on localhost by default. Next, let's proceed with task 6, test connection to the database. So first we will export this Google project ID. So we will create a variable by the name Google project, and we will export the project ID value to this variable, so that we will get it from gcloud config get value project. It will fetch the project ID and it will set the ID to this variable. Copy this. Now it is set. Next we are setting this MySQL DB name and also the connection name. Copy this. Next we are starting the Cloud SQL proxy for the Cloud SQL instance. So to start we need to execute /Cloud SQL proxy, and under instance we are providing the SQL connection name. So here we are providing the SQL instance name and the port number we are specifying here. Let's copy this. Let's open a new tab. Let's navigate to this directory. Copy this. Now we are inside this directory. Let's get the generated password for MySQL. Copy this. So we got this password. Next we will test the MySQL connection. So this has established the connection. So next we will test the MySQL connection by executing MySQL default username, password, and the host ID here we are passing. So let's copy this. So it's asking for password. So that password you need to copy the above one and paste it here. See, now we have connected to MySQL. If you want to come out of this, we can just do Control D. It will exit out of this SQL instance. Which command is used to create a Terraform execution plan? For execution plan, we use Terraform plan. The Cloud SQL proxy provides secure access to your Cloud SQL instance without having to allow list IP address or configure SSL. That is true. So in this lab, we saw how to create a Cloud SQL instance using Terraform, and we also set up the Cloud SQL proxy. We then tested the connection between the two with the MySQL client. So once you complete all the tasks in this lab, you can click on End Lab. I hope this video was helpful. If you have any questions or feedback, you can leave your comments under comment section. Thank you all for watching. See you in the next video.